Hello everybody. Let us look at the worksheet for 11-2, the volume of prisms and cylinders. Starting with number 13, Dylan compares the volumes of two bottles. What is Dylan's error? He says they are equal because they have the same dimensions. But they don't have the same dimensions all the way around. The area, if you make a cross section of the prism, is going to be 16, 4 times 4. And the area of the cross-section of the cylinder is going to be 4 pi, or pi times 2 squared. So they can't have the same volume because they have different cross-sectional areas. So the area of a cross-section of the prism is 16, and the area of the cylinder is 4 pi. Again, that's pi times 2 squared. So they can't have the same volume. So they can't have the same volume. All right. Number 15, does rotating the rectangle about line M result in a cylinder with the same volume as rotating the rectangle about line N? But of course, if you're rotating around line M, the radius of the cylinder is just from M to the end of the shape. If you're rotating it around line N, the radius is everything in the length of the cylinder. It's going to go around that way. So what we can say is we can say no, around M would be a cylinder with radius x. We'll put an x there. So no, around M would be a cylinder with radius x, and around N would have radius 2x. But they'd both have the same height. But they would both have the same height. So if they have the same height but different radii, then obviously they're going to have a different volume. Number 16, do the prisms shown have equivalent volumes, and explain? Well, if we take this first prism and we take 1/2 the base times height of the base, we're finding the area of the base first. So that's 1/2 times A times 2B times the height of the shape, or the depth of the shape, right, going away from the base, times x. Then altogether, that would be A times B times x. And if we look at the other shape, we've got 1/2 times the base and height of the base to find the area of the base. So 1/2 times 2A times B times the height, again, the depth, right, this dimension that's not the base, of x. And that gives us A times B times x. So yes, both have the same volume. Have the same volume. Number 18, Talisa plans a 6-foot deep pond. While digging, she hits rock 5 feet down. How can Talisa modify the radius to maintain the original volume of the pond? Well, we've got to figure out what is the original volume of the pond. So we'll take the pond and we'll do the area of the base, pi times 3 squared, times the height of 6 feet. We find that that's 54 pi. So with the modified pond, we need the same thing. We need to have the same volume. So we need to have pi times the radius squared times the height, which is 5, we need that to be equal to 54 pi. So we can divide both sides by 5 pi. And we get that r squared needs to be equal to 10.8. So then we take the square root of both sides, and we find that r needs to be equal to 3.29. So the new radius needs to be 3.29 feet in order for the volume of the pool or the pond to be the same. Number 19, the instructions for plant food say to use 0.25 grams per cubic inch of soil. How many grams of plant food should Jordan use if the planter box shown is full of soil? That's simple. We're going to multiply to find the volume. 9 times 35 times 12, which is going to give us 3,780. Then we'll take 3,780 and multiply that by 0.25, because it's 0.25 grams per cubic inch of soil. We get 945 grams. Number 21, sections of 2 flood control ditches are shown. Which one holds the greater volume of water per foot? So this first one is a trapezoidal prism. Got a trapezoid base. So to find the area of the trapezoid base, we're going to say we've got the top base 60 plus the bottom base 40 over 2 multiplied by the height of the trapezoid, which in this case is 30 inches. So that area is going to be 1,500 inches squared, the area of a cross section. These both have the same depth, 1 foot, so we can just find the area of each base to compare the volumes, since we would be multiplying by the same number to find the actual volume. So whichever one has a larger base area is going to have a larger volume. Here we have a hemisphere, or not a hemisphere, I'm sorry, a semicircle. So we have pi r squared, pi times the radius of 30 squared, but over 2, because it's half a circle. That's equal to 450 pi, but to compare them exactly, we're going to need to change that into inches cubed. Or inches squared, rather. So we will need to simplify that to a decimal approximation of 1,413.7. That tells us that the trapezoid is going to hold more water per foot. 1,500 inches squared times 1 foot would be 1,500 inches cubed per foot. So the trapezoid holds more water per foot. All right, let's keep going. Inez's younger brother will be home in a half hour. If her garden hose flows at a rate of 24 gallons per minute, does she have enough time to fill the pool before he gets home? And explain. So we've got our pool there. We've got a thickness of our pool as well. So let's figure that out first. We've got to figure out how much is the diameter of the pool, going from the center just to the edge of where the water is. Because we know that the entire diameter is 9 feet, but it's got a thickness of 10 inches on both sides. So the radius of this pool is the first thing we need to find, or the radius of the water in the pool. If we take 9 feet and divide it by 2, the radius from the center to the outside is 4.5 feet. Minus the thickness of the pool. That's measured in inches. So I'm going to change that to feet by calling it 10/12 of a foot, 10 inches out of 12 inches. And then when I simplified this, I just turned it into a decimal altogether. I said the radius is around 3.67 feet. So then I'm going to find the volume of the pool by doing pi times the radius squared, pi times 3.67 squared, times the height of the pool, which is also in feet, so times 3. That gives me a volume of 126.94 feet cubed. So that volume is going to be multiplied because we need to know how many gallons it is. So we're going to take 126 cubed feet multiplied by 7.48 to figure out how many gallons it is. So 126.94 times 7.48, it's going to give us 949.52 gallons. And then we need to figure out how long it's going to take to fill the pool. And it flows at a rate of 24 gallons per minute. So I can take the 949.52 gallons and divide it by the number of gallons per minute, the rate there, and it's 24. That gives me the time, 39.6 minutes. But there's only half an hour until Inez's younger brother gets home, so there's not enough time. And there we go. Let's keep going. This one's always fun. The ABC Cookie Company wants to promise an average of 12 chocolate chips per cookie. Assuming the cookies fill about 80% of the box by volume, will 600 chocolate chips for each box of cookies be sufficient to make the claim? And explain. There's a lot going on here. We're going to have to find two volumes, the volume of the cookie and the volume of the box. And then we'll need to compare both of those. So for the volume of the cookie, we've got pi times the radius. Diameter is 3, so radius is 1.5 squared, times the height, which is 0.5 inches, gives us a volume of 3.53 inches cubed for each cookie. Then we're going to find the volume of the box, which is, of course, 6.5 times 9.25 times 3.5. The volume of the box is 210.4 inches cubed. However, the cookies only fill 80% of the box. So we need to figure out what 80% of that volume is. So we'll take the volume, 210.4, and multiply it by 0.8, 80%, to figure out that 80% of the volume is 168.32 inches cubed. Since 80% of the box is full of cookies, and each cookie is 3.53 inches cubed, we can take 168.32 inches of cookie, divide it by 3.53 inches cubed of cookie to see exactly how many cookies that is in the box. That is 47.68 cookies per box. Right? And then they want 12 chocolate chips per cookie. So we're going to take that amount of cookies and multiply it by 12. And so we'll take and round up there because it's closer to 48 cookies. So we'll take 48 cookies times 12 chocolate chips per cookie. That would mean one box has 576 chocolate chips in it. And since we were wondering if 600 chocolate chips would be enough, yeah, because 576 chocolate chips would make an average of 12 chocolate chips per cookie. So yes, 600 chocolate chips will be enough. All right, keep going. 25 cylinders A, B, and C have the same volume. Cylinder A has diameter 12 centimeters and height 8 centimeters. If the diameter of cylinder B is 16 centimeters, what is the height? Well, let's find the volume of cylinder A because A and B have the same volume. So cylinder A is going to be pi times the radius of 6 squared times the height of 8. So that is 288 pi centimeters cubed. And then we can use that to find the to find the height of B, because we'll say pi times, and we have the diameter of 16, so the radius is 8 squared times the height of B that we don't know. is equal to the same volume as A, 288 pi. So then if we solve for the height there, we would divide both sides by 64 pi, because 8 squared pi. And we would find that the height is equal to 4.5 centimeters. Then part B, if the height of cylinder C is 32, what is the diameter? Notice they asked us the diameter, not the radius. So we're going to take the same volume of 288, and we'll say pi times the radius, we don't know, squared, times the height of 32 is equal to that common volume of 288 pi. Then we can go ahead and divide both sides by 32 pi. And that gives us r squared on its own. The radius squared equals 9, which of course means the radius equals 3. They want the diameter though, so we're going to have to double that. And the diameter is going to be equal to 6 centimeters. And finally, if the volume of the prism shown is 70 cubic yards, what is its length? Well, let's work backwards. We'll take the area of a base, 3.5 times 5, base times height over 2, multiplied by the length of the prism, and it's equal to 70 yards cubed. So then we can figure this out. I'm going to do 3.5 times 5 over 2. That's 17.5 times the length equals, they did 3.5 times 5 and then multiplied everything by 2. So it's equal to 140. So I multiplied by 2 and then did 3.5 times 5. Divide both sides by 17.5. And I find that the length is equal to 8. So B is the answer there. And that's everything for the 11.2 worksheet. Let me know if you've got any questions and have a wonderful day.